Exercise 10.4, question number 1. See, we have two circles. First circle of radius 5 and second circle of radius 3. And the distance between the centers is 4 centimeter. That is given in the question. We need to find the length of the common chord. So, AB is the common chord. We have to find what is AB. So here we have to consider OA O dash and OB O dash. These two triangles, and listen, in these two triangles OA O dash, OA square is 5 square 25. Then O dash A square is 3 square, that is 9. Okay. Now O dash square. What is O dash square? The length is given 4. So 4 square plus 9 square is 25. Isn't it? 16 plus 9 is equal to 25. Therefore, this result means Pythagoras theorem. Base square plus altitude square equal to hypotenuse square. So 5 is the longest side, and therefore this angle is equal to 90 degree. Similarly, this is 3, this side is 4, this side is 5. 3, 4, 5. So 4 square plus 3 square is 25. So in this triangle we can apply Pythagoras theorem, and therefore this angle is equal to 90 degree. So angle AO dash O is 90 degree. BO dash O is 90 degree. Now listen. So listen, these two angles are 90 degree. So 90 plus 90, 180. That is AO dash B is 180, means AO dash B is a straight angle, or OO dash B is a straight line. So this is a straight line, means this O dash joins with M or coincides with M. That is AO dash B line is same as what? AMB line. Okay. So this length AB is equal to 3 plus 3. 3 plus 3 is equal to 6. So length of the common chord is equal to 6. Okay. See second question. If two equal chords of a circle intersect within the circle, then prove that segments of one chord are equal to corresponding segments of other chord. Okay. Listen the figure. See the figure. This is the circle. Okay. And here chords, two chords are given, and these two chords are equal. So this is one of the chord and this is another chord. These two chords are equal. Let us take this chord as AB, this chord as CD. And these two chords meet at a point M. This is center. Now join OM and draw two perpendicular from the center to this chord. This is L, perpendicular, and this is N, perpendicular. Now listen, we need to prove segments of the corresponding chords are equal, means this is one of the segment BM. So this segment is equal to DM. We need to prove BM is equal to DM. Then another segment is AM, small segment. And this AM is equal to small segment of this chord. AM is equal to CM. That we need to prove. Okay. So listen, consider these two small triangles, and here OM is common side, isn't it? OM is equal to OM. Now AB and CD are equal chords, therefore ON and OL are equal. What is the reason? If chords are equal, then the perpendicular from the center are equal. Now these two angles, angle OLM and angle ONM, both are equal to 90 degree. So we have a right angle triangle, hypotenuse and one side. Therefore by RHS congruence rule, these two triangles are congruent. OLM is congruent to triangle ONM. Here apply CPCT rule. We can see that LM is equal to NM. Okay, LM is equal to NM. Now listen, given that chords are equal, AB is equal to CD. So what is half of AB? Half of AB is equal to half of CD. So half of AB means DN, AL or DB, isn't it? So consider BL. Half of CD means CN or DN. So take CN. BL is equal to CN. Now add LM on both sides. BL plus LM. Similarly CN plus LM. Here LM is equal to NM. Okay, so put LM here, NM. CN plus NM. Now look at the figure. What is BL plus LM? BL plus LM. It is BM. BL plus LM is BM. CN plus NM. Look at the figure. CN plus NM gives CM. That means BM is equal to CM. Similarly, we can prove AM is equal to DM also. Okay. So this is the meaning of segments of one chord is equal to segment of corresponding segment of other chord. Okay. So that is question number 2. Now question number 3 is same question. Listen. The same question means chords are equal are given and we need to prove line joining point of intersection to the center makes equal angles. So this OX line makes equal angles at the center. That is, we need to prove these two angles are equal. See, in the last question, question number 2, we proved these two triangles are congruent to each other. Similarly, we need to prove triangle OMX, ONX are congruent. Same results by RHS. Okay. And here apply CPCT rule. We get OXM angle. OXM is equal to OXN. Okay. Now question number 4. See, this is a circle. Concentric circles. Concentric circle means circles having same center. O is the center of smaller circle. O is the center of larger circle. And BC is the chord of smaller circle. AD is the chord of larger circle. So in the question we need to prove AB and CD. These two are equal. So consider the smaller circle. OP is the perpendicular line from the center to the chord BC. Therefore this line bisects the chord. That is BP and PC. These two are equal. Okay. BP is equal to PC. So, OP is a perpendicular line and the perpendicular line bisects this chord AB also, isn't it? That is AP is equal to PD. Now just subtract equation 2 and equation 1. AP minus BP, PD minus PC. Look at here. AP minus BP. Total AP minus BP gives AB part. Total PD minus PC gives CD. Okay, so that's our question number 4. Yesterday we didn't discuss these 4 questions belongs to exercise 10.4. Okay, so note down all these things. Question number 8. So in the question it is given that ABCD is a trapezium. Trapezium means one pair of opposite sides are parallel, other two sides are opposite sides are non-parallel. But in the question it is given that these non-parallel sides are equal. AD is equal to BC. This is given. Non-parallel sides are equal. Okay. So to prove that, listen. This is a cyclic trapezium. Cyclic trapezium means we need to prove opposite angles are supplementary. Sum of these two angles equal to 180 degree. That we need to prove. Angle A plus angle C is equal to 180 degree. For this, draw a perpendicular line from D and from C to the base AB. Suppose it is M, it is N. Okay, this is perpendicular. Now consider these two small triangles and prove these two triangles are congruent to each other. So listen, triangle AMD and triangle BNC. Look at this triangle. Here AD and BC are equal, given that non-parallel sides are equal. Now DM is equal to CN. DM is equal to CN. What is the reason? This is a rectangle, therefore opposite sides are equal. Okay. Now see these two angles. Angle AMD and angle BNC. Both are equal to 90 degree because of our construction. So we have a 90 degree right angle triangle, hypotenuse and one side. So by RHS congruence rule, triangle AMD and triangle BNC are congruent to each other. Okay. Here apply CPCT rule. By CPCT rule, we can write, listen, angle DAM. Okay, DAM is equal to CBN. Angle CBN. Look at the figure. DAM. DAM means angle A, isn't it? Angle A. Now CBN. CBN means angle B. That is angle A is equal to angle B. Okay. Angle A is equal to angle B. Now listen. ABCD is a trapezium. Therefore, AB and CD are parallel side. Okay. AB and CD are parallel side. So these two are parallel sides. AD it's transversal, isn't it? AD it's transversal. Therefore, angle A and angle D. Listen, angle A and angle D are angles lie on same side of the transversal. Therefore, they are supplementary. Sum of the angles equal to 180 degree. Is clear? ABCD are parallel. AD is transversal. Therefore, these two angles are co-interior angles. Angles lie on same side of the transversal. Therefore, their sum is 180. Now listen, in this A plus D, we can replace angle A as angle B. What is the reason? Because we already proved angle A and angle B are equal. So we get angle B plus angle D is equal to 180. Look at here, angle B and angle D. Sum of these two angles is 180 means opposite angles are supplementary. Opposite angles are supplementary means A, B, C, D is cyclic. Okay, A, B, C, D is cyclic. So that is question number 8. Question number 9. See, we have two circles. Two circles intersect at 2 points B and C. Okay, intersects at 2 points B and C. Through B, draw a line segment A, B, D. Okay, through B, draw a line A, B, D. And through the same point B, draw a line P, B, Q. Okay. Now, these lines ABD and PBD intersect circles at A, D, then P, Q. Is clear? We need to prove that angle ACP. So, join ACP. So, this angle ACP. This angle is equal to, listen, angle ACP. This angle is equal to angle QCD. So, join QC and QD. So, these two angles we need to prove are equal. So, for this, let us take this angle as 1, this angle as 2. Okay. Now take this angle as 3. Listen, this arc AP. This arc AP makes an angle at a point B. At a point B. What is it? Angle ABP. That is angle 3, isn't it? The same arc AP makes an angle at a point C. What is it? Angle ACP. So the same arc AP makes two angles, ABP and ACP. So these two angles are angles in the same segment, and therefore these two angles are equal. Angle 1 is equal to angle 3. Okay. Now listen this angle. Suppose it is angle 4. What about these two angles? These two angles are vertically opposite angles. So angle 3 is equal to angle 4. Okay. Angle 3 is equal to angle 4. Now angle 4 is actually angle QBD, isn't it? Angle QBD. So angle QBD is the angle made by this arc QD. So this arc makes an angle QD at a point B. Now listen, the same arc QD makes an angle at a point C. What is it? QCD. So angle QBD and angle QCD are equal. Now angle QCD is 2. Okay. So listen, angle ACP is equal to angle ABP because angles in the same segment. Angle ABP is equal to angle QBD. What is the reason? Vertically opposite angles. Now angle QBD is equal to angle QCD. What is the reason? Angles in the same segment. Now look at here. ACP and QCD. These are the two angles. ACP and QCD. These two angles are equal. Okay. Number 10. Listen. Two circles are drawn. So in these two circles, we draw a triangle in such a manner that, listen, two sides of this triangle as diameters. Okay. So in the triangle ABC, AB side and AC side, these two sides are diameters of these circles. We have to prove that the point of intersection of these circles. So point of intersection of these circles means this is the next point of intersection, D. This D lie on the third side. What is the third side? Third side is BC. So D lie on third side means BDC is a straight line. That we have to prove. Okay. For this, join AD. Let's join AD. So AB is the diameter. So what is the angle ADB? AB is the diameter. So what is angle ADB? Angle ADB is the angle in a semicircle. Therefore, this is 90 degree. Okay. Now consider this circle. What is AC? AC is diameter. So what is angle ADC? ADC is the angle in this semicircle. So angle in the semicircle is 90. So these two angles are 90 means this angle is 90 plus 90, 180. So 180 means BDC is a straight angle or BDC is a straight line. That is D, the point D lie on the third side BC of the triangle APC. Okay, so we apply only one concept here, angles in a semicircle. So consider this semicircle, therefore this angle is 90. Consider this semicircle, therefore this angle is 90. So total angle is 180. 180 means BDC is a straight line or D point lie on this line BC. BC is our third side. Okay, so that is question number 10. Number 12. ABCD is a cyclic parallelogram. We need to prove ABCD is a rectangle. Okay. So ABCD is a cyclic parallelogram, means it is cyclic quadrilateral plus parallelogram. So cyclic means all the vertices lie on the circle. Parallelogram means opposite sides are equal and parallel. We need to prove ABCD is a rectangle. Okay. Now listen, to prove ABCD is a rectangle, we have to prove that opposite sides are equal and parallel. Okay, opposite sides are equal and parallel. Then all angles is equal to 90 degree. All angles are right angle. Okay, listen. Given that ABCD is a parallelogram, so parallelogram means opposite sides are equal and parallel. So no need to prove this condition, it is already existing because of parallelogram. So we need to prove all angles is equal to 90 degree. Now listen, ABCD is cyclic quadrilateral also. Okay, so cyclic means opposite angles are supplementary. That is, angle A plus angle C is equal to 180. Similarly, angle B plus angle D is equal to 180. Okay, because of cyclic. Now parallelogram. Parallelogram means opposite angles are equal. That is, angle A is equal to angle C. Angle B is equal to angle D. So put angle A is equal to angle C here. So this becomes, listen, angle A plus angle A equal to 180. 2 angle A is equal to 180, or angle A is equal to 180 by 2, that is 90 degree. Okay. Angle A is 90. If angle A is 90, then angle C is also 90 because of parallelogram. Opposite angles are equal. If angle C is 90, then angle B is also 90 because AB and CD are parallel. So 90. These two angles are lie on same side of this transversal, isn't it? Now, if angle B is 90, then angle D is also 90 because ABCD is a parallelogram. So, all angles equal to 90 degree means ABCD is a rectangle. Okay. So, that's about our exercise 10.5. Okay. Hi students. In this chapter, circles, we were discussed some results, theorems and cyclic quadrilateral. Okay, each and every theorems are very important, and cyclic quadrilateral property is also another important concept. So write and study each and every questions belongs to exercise and examples given in your textbook. And also I give some assignments problems for you. Write and send it back. Okay. So anyway, thank you all. Have a nice day.